You have not had a chance to watch the video about the wise man who invented the game of chess, you should go back and watch that video. So, if you've watched that video, then let's get started here. Okay, in the video, there was a wise man who determined, or he basically said, the king said, I want to reward you for inventing the game of chess. And the wise man said, okay, if you're going to reward me, then give me one grain of rice, I believe, one piece of rice on the first square of my chessboard, and then on the second square, put 2 pieces. And then on the third square, put 4 pieces. Okay? So what that was looking like was this. On day 1, so we'll call X the number of days, and Y, so this was number of days, and Y was pieces of rice. Okay? On day 1, there was 1 piece of rice. On day 2, there was 2 pieces of rice. On day 3, there was 4 pieces of rice. On day 4, there was 8 pieces of rice. Okay, now, 8 pieces of rice, that doesn't seem like very much. The thing that's interesting, though, is that if you watch the video, it didn't take very long, and the amount of rice that the king was paying the wise man was an amazing amount. Okay? What that is a demonstration of is exponential growth. All right? How do you know something has exponential growth? Well, remember when we were doing linear growth, there was an add pattern over here. If he had been saying, if the wise man had been saying, just add 1 piece of rice every time, then, or even let's see, if he would have said, look, we'll start with 2 pieces of rice, and on day 2 I'll have 4 pieces of rice. On day 3 I'll have 6 pieces of rice. On day 4 I'll have 8 pieces of rice. Okay? This would be called linear growth. And that's what we've been dealing with for forever. Linear functions, right? Linear growth. Okay? Remember, there's an add pattern happening over here. And we talked about that a lot. Okay? Now, here, it seems like, oh, well, there's not very much of a difference, an advantage of having a multiply. But look what the wise man said. He said, look, instead of adding 2 every time, what I want you to do is I want you to multiply by 2 every time. Okay, so he would go, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And if we went to the next one, on day 5 here, there would be 16. Over here on day 5, there's only 10. And the numbers get greater and greater and greater in difference as we go along. Okay, so as you can see, I changed the table up just a little bit. It's still the same story. It's still exactly the same thing. But what I did do was I called this day 0, and you're going to see why here in just a minute. So what we're saying is that the king gave the wise man 1 piece of rice. That was the beginning of this whole process. Then 1 day later, he gave him 2 pieces of rice. Then 1 day later, he gave him 4 pieces of rice. 1 day later, okay? So it's still the exact same equation, but it's going to fit what we're going to do here just a little bit better, okay? So here we are. Y equals A times B to the X. Okay, this is what we call an exponential function. This is general form of an exponential function. Now, that looks a little different. That looks a little different than, remember our other one, our linear? Remember linear looked like this. Y equals mx plus b, right? Mx plus b. Well, what's one thing that you know that's different? Well, notice in this case, there is no exponent, right? It's raised to, our x is raised to the 1 power. We never really wrote that because you don't have to. But in this case, where's our x? Our x is now in the exponent. All right, so that's a big difference. So if you see something like this, and you say, okay, now wait a minute, I can see right here, this is multiply by 2, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. I definitely see a multiply pattern here, okay? If it's a multiply pattern, then you know you got exponential growth. If it's an add pattern, then you know you've got linear growth. And we're going to talk about these two things side by side in just a little bit. Let's look at the features of this equation, okay? So we're going to start with y equals, okay, well, where do we get the a? Well, guess what? Just like in when we were doing linear, the a comes right here. That is our y-intercept. When x equaled 0, the y was 1. So a is whatever crosses the x-axis, and you're going to see that on a graph here in just a second. Okay? Times, well, what's the b? The b is whatever your multiply pattern is. So in this case, it's 2. 2, now what's your x? Well, the x is a variable, and the x changes here every time. So let's see if this equation works. Okay? So if I took, let me grab a blue marker and let's see what happens here. Okay, so so I say y equals 1 times 2. Let's choose x to be 2. Okay? Well, what is 2 times 2? 2 times 2 is 4. Or, sorry, 2 squared is 4. Times 1 equals 4. Sure enough. Okay, well, let's go choose another random one. Let's go down here to 5. Okay, what if we had y equals 1 times 2 to the 5th power? Okay, well, what is 2 to the 5th power? First of all, remember, we always have to raise our exponent. A lot of kids are going to make a mistake by multiplying here first. No, do your exponents first. Okay, so if we went 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32, times 1 equals 32. Well, guess what? Bam. Right there. When you plug the 5 in for x, the y value was 32. Okay, just one more. I know you guys got it. I'm sure of that. Okay, well, let's just go here. Y equals 1 times 2 to the 8th. Okay, so this is probably where you need to make sure you have a calculator for this assignment. You can use your calculator on your phone. You might just have to turn it sideways. You need to have exponents, right? And so if I went 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. Sure enough, 2 to the 8th, 256. Bam, times 1, right? Y equals 256. Okay, so now I'm going to show you just something else just here in just a little bit. Same equation. What have I done now? I've built my table. I've changed my numbers on my table just a little bit. Same exact equation. We still had 0, 1. Those numbers are all the same. Now I started a graph. Okay? So one thing that you're going to notice, a really big feature of an exponential function is this table thing here. And we're going to talk a lot, this tail that really starts to go whoop, really steep. We're going to talk a lot about that. And we're going to talk about why if you're a saver, if you're somebody who can save some money, that tail is really a big deal. And why banks are full of a lot of money and people that borrow from banks are not. But we'll get to that here in just a minute. Okay. But what I wanted to talk about is I want to say, okay, well, we haven't talked at all about what happens over here in negative land. Okay, so we got to talk a little bit about that. So if I say, okay, so if we have y equals 1 times 2, now I'm going to go back here to negative 1. All right, this is why I had you do that worksheet, because I needed you to remember something. What is 2 to the negative 1? Well, y equals 1. 2 to the negative 1 is really the same as 1 over 2 to the 1 power, right? Remember the negative exponent? That's why we did this. Well, what is 2 to the 1 power? 2 to the 1 power is just 2. Well, what is 1 divided by 2? It's a half. A half times 1 is a half. All right. Okay, let's see. What do we do now? Let's try the next one. Y equals 1 times 2 to the negative 2. 2 to the negative 2 is the same as y equals 1 times 1 over 2 squared. Well, what is 2 squared? You guys already know that 2 squared is the same as 4, right? So 1 times 1/4. Oh, well, that's just 1/4. All right, now let's look at what's happening here. If we were working this way, a half, 1, 2, 4, 8. What's happening every time? It's doubling, right? Well, what if I work backwards? 8, 4, 2, 1, a half. Getting ahead of myself. That's supposed to be a fourth, right? Half of a half is a fourth. Well, what's half of a fourth? That's an eighth, isn't it? All right, let's look over here at our tail. So here we go. Negative 1 is a half. Negative half is a fourth. Sorry, negative 2 is a fourth. Negative 3 is 1/8. Okay, now what's really going to happen is this line is going to get infinitely close to 0, but it never actually hits. Okay, and there's actually a name for this thing right there. That is called an asymptote. Every exponential function has an asymptote, and we're going to talk about that later on as we get going. So, what you're looking at here, you think that's funny that I said asymptote? I know. There's some jokes in there that could be made, I'm sure, but we'll pass on making jokes about asymptotes. Okay, anyway, so Tawny's got me all flustered now, thinking about asymptotes. Okay, so anyway, every exponential function looks like this. It's got this long period of where nothing's really happening, and then all of a sudden it starts to climb and goes crazy, okay? On tomorrow's video, I'm actually going to show you a video about exponential growth that's pretty cool, but it also talks a lot about the COVID-19 virus and why it was so important for us to, what they talked about, which was leveling the curve or whatever they were saying, right? And why they thought it was important for us to close school down, and that really has a lot to do with these exponential functions. It doesn't grow at all for a really long time. It stays flat, stays flat, stays flat, then all of a sudden it goes crazy. Okay, that's a feature that we're going to talk a lot about these graphs. So I know I spent a lot of time introducing this stuff. Now we're going to start going a little bit faster. So now we're going to talk about just very quickly graphing these things, all right? And so what I want to show you here is I want to show you that actually, I know I did a lot of talking in the first one, but these can be graphed very quickly. Where I always start, is I always start here at 0. Remember what I said, that number is our y-intercept, right? So we already know that this is 1. Well, how do you know that that's 1? Well, here's what we would do. We would say y equals 1 times 3 to the 0 power. Well, what is 3 to the 0 power? Anything raised to the 0 power is 1. We talked a lot about that previously. So anything raised to the 0 power is 1. So we know this whole thing here is 1. 1 times 1 is 1. Bam. Okay, now remember what I said. That this number right here tells you your pattern. Well, what are we doing? We're multiplying by 3, right? So here we go. 1 times 3 is 3. Okay, well, and then I'm just actually going to fill this thing out right now. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Okay, now what if I went backwards? Divided by 3, divided by 3, divided by 3. So what would this thing be? That would be 1/3. Well, divide that by 3. Well, that's 1/9. Divide that by 3. Well, that's 1/27. Bam, I've already filled that out. Okay, now I know that went really fast.